Hello, welcome back to the StackIt series, and today we're gonna do something a little bit different. Just to follow up on last time, we were looking at a certain position, and that came up in one of my games, and why just one move after following the principal variation, it changed its decision completely. So wait, maybe I'm going to show it so it's easier to understand. We were at this point in the game, and according to the previous principal variation, it would play the move 2-0 and I would play the move 3-1. And this would result in a negative score of -12 for the AI. And if you look at it and saw my video, I said, okay, I'm going to be cheating here. I'm just going to follow the principal variation because I would actually top this one over instead. Because it actually just threatened to top my stone over. And then we see after playing this move, suddenly it says, oh, by the way, actually I'm going to be really good, well off in the end. And we were looking in why this happened. And last time I looked at it and tried to figure out if anything in our search is wrong. So I went back to this exact position and ran the search again. And we can see here it has the same principal variation. And then even if we search deeper and wait much longer, it doesn't. If we search deeper, 1 second, which one is the interesting one? 10 would be the next interesting one. It actually finds a different move and suggests for me to top over instead of putting a 3-1. But it doesn't find that it has a very high positive score. Why does this happen? I said we would need to play until then and see how the evaluation goes. But what I actually remembered happens, and I've been talking over and over and over again, is that we should do a quiescence search at the end, because what happens here, it goes down to depth 8, and in the last depth, if you play out the moves that should happen here, you will see that we will get to a board which is similar to this one. And here the AI now says it should top over this this stone, basically capturing everything, and then in the next move it would lose a lot when I top over this one. And then it doesn't search any deeper because the search of depth of 8 is actually done. So it would stop at this point in time, but actually what it doesn't see is that after I top this one over, it can top another one over and basically capture the whole field, I think. So what would happen, or what I expect to happen, and we can try this now, is if we implement this quiescence search, or we just enable it again, at position 8, it would still play out all the valid capture moves, and then it would see that actually playing here is very bad for player 2, because it will get to the spot where green can just play anywhere on the field, waiting for me to top this over and essentially then lose everything. So the way this works is, instead of returning the score here, we will return quiescence board, and then let's say we can go, let's limit this for now, we can go an additional depth of 10, and then this one will basically return our score. If there's no possible moves, this is only the attack moves, or the depth is 0, we just return the score. Else we say the max score is really bad, and we go through and we play each possible attack move, and we check what's the maximum score. So I think unfortunately we have to wait a little bit now for this to do all the calculations. It seems very slow. Here we went down to depth 6 immediately. This is now because I do this quiescent search in the end all the way, but we can actually check. So it says already -4 at depth 1. Here it says 3. Here it says 10 at depth 2. Here it says -6. And this is what I meant before. You can see how much longer it takes, because of course now technically, if there's a depth of 10 possible capture moves, it will go down to depth 12 instead of depth 2. Overall, we should get a more accurate result though. And you can see at depth 11, it already said we should play at 0, 1. At 12, it says we should play at 2, 0. 0, 1, 0, 1, play here, and then 1, 1. Top this over. 0, 2. Yeah, something like this. Okay, this is interesting. Exit. Let's see if I can. What happens if I make this 100? Like, how deep does it go? Is it actually finishing? This is so crazy. See, then even 1 doesn't finish. This is crazy. Let's see if this is actually true. So in order to figure this out, we have to go here. We do print move board print. Nope, I didn't mean this. I meant board print. And then we wait for input so we can see. Oh. And here we can also say that depth. Okay. Okay. This is the first capture move. We will play 0, 3. 0, 0, 3. 1 second. 0, 3 is not a capture move. Yeah. Let's just see real quick. We played 0, 3. Did we? No, maybe this is. 1 second. Did anything change? 0, 3. Is this inverted somehow? Am I rotating stuff? Then you can see we immediately generated a couple of new. Then we have 3, 0, which would be 3. I have no idea what's happening here. 0, 2. Now we throw this over, now we throw that over, now we throw this over, now we throw that over. And here you can see this was a depth of 6. And now it's quiet. Now we go 1 back up. There's nothing. There was another one here. Why did we do this move again? 3, 3. 94, 3, 3, 94, 3, 3. Why did we play this one again? This is another way to reach this state, because here, 1 second, here we have 3 4s that we can top over. Okay, and then if we apparently move over, here we can play another one. You see how many variations there are? This is crazy. One second. How can we make this a little bit easier to understand? In our alphabet. So if I move, let me just think. So if a move tops over, we don't need to play all the adjacent moves anymore, which should sometimes reduce the search space. So, you know, in these possible moves, if we top one over and right next to it there's another one that will automatically top over, we don't need to try this anymore. So we can have a set of excludes, and then we can say for every move if move in excludes, continue excludes add move 0 plus 1 move 1, something like this. So we add this one. It's now a bit ugly, whatever, it works. Plus 1 minus 1. So basically, if there's any 4 right next to us, we don't need to do this anymore. Here we do. We kill this one, do it again. Perfect. Okay. Okay, this is at a search depth of 0. We should probably also print depth possible moves once we start. Depth move score, something like this. Okay, this will help us debug this a little, but I fear this is just how it is, and then there's no good way around it actually. Okay, so we have 0, 3, 0, 3. This is so funny, and 3, 3. Why 0, 3? For player 2, we should actually have 3 of them. Let me just see what's happening here. If not player, and field equals 4. Okay. We only want to have fields of the current player, and the field is 4. Zero, 3, and 3, 3. Print x, y. Field. Now we're gonna find bugs in our move function. Okay, what do we have here? We have 0, 0. Okay, 3, 0. This is this one. Ah, yeah, and then we should check what's this one. The current player. Okay, now we have it. Wow. Okay, and player equals 2, but current player equals 1. Here we have it. 421411030. 3 is wrong. What's happening here? 3 3. Y coordinate stays the same. X is this, and then 4 3 0 4 4 4 3 0 4. This is a rotated board or something. Board. Alpha beta. Let's check. Zero zero is a 3 of player 2. Yeah. 3034. 3034 is correct. 1430. 1430. This is also correct. 3143. 3143. Oh, yeah. 3143. Oh, wait. Everyone saw it already except for me. I am printing the board after I make the move, which is a little bit hard to interpret because okay, cool. This is probably all right. Okay, let's see. Okay, now we're on this board, and then we can do 0 3 and 3 3. Okay, everything's good. I just had a not so good way of printing it. Okay, and we decide to go with 0 3. Zack. Okay, now we can do 3 0 1 1 2 2. We decide to go with 3 0. Okay, now player 1 can go with 0 2 1 3 3 3. It goes with 0 2 2 0. Player 2 goes with 2 0. Okay, bam. Now we get to this one. Here we go with 1 3 3 3 1 3 3 3. Okay, top this one over. Goes with 1 1. And then 3 3. And that returned a score of 7 on a board where there were no moves. Okay, cool. This is once we top this over, everything is topped over, and that is a score of 7 for, let's see, this one will become a 1, this one will be a 2. Oh, this is a bit hard. I assume this will be, this currently player 7 is for player 2. Okay, and then here 1 1 returns a 7, 95 2 2. Yeah, we played 1 1, we played 2 2. Returns a 7, we play 3 3. Yeah, this one now. Okay, we only skipped this one because yeah. This is okay. Now we skip this one. Now we do this, and then that, and this. Yeah, as you can see, this is endless variations. I wonder if I should make it in the main game that you have to press return every time something tops over, just so you can see what's happening. And this is at search depth 0, mind you. So I wonder if we minus 25. Minus 25, what happened here? Oh yeah. Okay, let's see. Let's comment this out for now. We don't need any prints anymore. And then exit, perf this one. If we play 2, 3, 2, and 3, we end up with a minus 2. You can see we searched 10 regular moves, but 4,500 quiescence search moves. This is not good. And I don't see any good way we can do this. Like one thing we could do is we change our maximize function to only do quiet moves if depth is 0 and only return scores if there's no moves left. So possible moves, there would be an if around this one, so we actually include all of these quiescence search stuff into our hash table. See, we don't even get to search depth 2 in a reasonable time because we have so many quiet nodes to search. Okay, let's see. If depth smaller equals 0, else, yeah, this is the normal, this is the possible attack moves. Wow. Okay, now the fan starts taking over. Let's stop this. This is nonsense. And then we comment this out. So now if we go below 0 depth, we actually only search for attack moves, and then we can immediately say if not possible moves, then we return the score like we did before. I should really get used to this. Like this. Let's try if this has any impact. Yeah, here we should ouch. Here you can see that actually we seem to have recursed quite a bit. If depth smaller minus 100. Let's just see. This is a bit ugly. I will probably remove this, but somehow we need to conquer this horizon effect. Three. Okay, you can see this is also killing us. See how many quiet moves we make. 16,000 versus 700 regular moves. And this is even not counting these. Maybe 10 captures, 6 captures in the future. We still have some horizon. Two zero. I guess 3 0. Yeah. This is definitely the correct line, because the other one, as we saw, will lead to a loss for the other player. So our algorithm will find an optimal route for both players, right? And 3-1 was definitely not the optimal move. And this seems to be a more or less reasonable trade-off between having a horizon on the attack moves. It still has one, so we will still find moves where it wouldn't be correct. Two zero. Yeah. Okay, are we gonna remove this or are we gonna leave this? This seems to be more accurate than what we had before, and it also seems to have a reasonable performance. We used to search until 8 in 20 seconds. Now we search until 6 in the same time. Okay. I think we'll leave it. And then I said in the beginning we're gonna do something very different. I would actually, while I have a blog post open from, let's credit, from Michael Liu about Monte Carlo tree search, which kind of explains the algorithm again, so I know how I can implement it. And while I want to do this and then just duke out both algorithms against each other, I also thought it would be nice to work a little bit more on the usability of this, and then also maybe have a simple front end that I can spawn on Python anywhere or something. So I'm not sure what I'm gonna continue. Let's see what I feel like doing. See you next time.